Hey, welcome back. We have just finished writing, compiling, and running our first program, but we've sort of glossed over the compiling part. We're going to discuss what the compiler is. You're going to come away from this understanding why we need to compile our code and also how the compiler is capable of detecting certain kinds of errors in our code. We'll wrap it up by talking about whitespace and comments and how those are ignored by the compiler and how they can be used to make our code more clear. So let's dive in. Now, we are human beings, unless of course you're an extraterrestrial, in which case I'll just say we are non-machine beings, unless you're an AI, but the point is that we speak in human language. We use human words, and even the C++ programming language is closer to our spoken word than the language that machines use. You see, machine language is nothing but a bunch of zeros and ones. Now, you might think it odd that a language exists made of only zeros and ones, but it does. It's called binary, and it's the only thing that machines understand. We can't just take our C++ program and hand it over to a computer. C++ contains human words in it. Words like include and main and print. Humans can understand C++, at least the superior ones. Just kidding. Tell your Python programming friends they're just as cool as you. But to a machine, it's all gibberish. Because certain humans can understand C++, we refer to it as a high-level programming language. Now, what we can give to the computer is machine code. True machine code is binary, meaning it consists of only zeros and ones. We refer to it as low level because it's close to the hardware. This is what the machine is happy with. So we need something that can translate our C++ code into machine language. That, my friends, is where the compiler comes in. We write our source files and then we hand those over to the compiler, which processes them and produces the binary information that the machine can read. Now, this is simplifying things a bit, but for now, all you need to understand is that we need to compile our programs in order for them to run. The compiler plays the role of translator between C++ and machine language. Now, the compiler is capable of detecting certain errors in your code, such as missing a semicolon. Compilers generate error messages when they detect mistakes they can recognize. These simple mistakes are called syntax errors. Syntax is just the rules regarding the symbols of C++. Now here is a challenge for you. I want you to introduce an error into your code intentionally. In our hello.cpp source file, remove a closing parentheses from one of your printf calls. And then I want you to observe the error that you get in the terminal. Go ahead and pause the video and give this a try now. Okay, we're back and we're ready to cause some mischief in our program. Here's hello.cpp and here are my 3 printf function calls. I'm going to take this final function call and remove the parentheses from the end. Now I'm going to compile by going up to Terminal and clicking Run Build Task. Now I'm going to drag the line up down here to see what the terminal has to say. And here we see that it started the build, and now it's saying in function int main error expected parentheses before the semicolon token. You see, it calls these symbols tokens. It's even showing me the line and where it thinks the closing parentheses should be. It's trying to help me out here. It's saying, hey, I think you forgot your closing parentheses here. Now there's also this problems section, and if you click on that, it shows you expected closing parentheses before the semicolon token. So this is kind of the gist of the error message. Now if you click on this, it'll take me exactly to the line that's causing the problem. And we even get a little red squiggly here showing us that there's something wrong here. So all we need to do is click there and put in our missing parentheses, and now we can recompile this. So go up to Terminal, click Run Build Task, and now we get build finished successfully. No problems, no errors, everything looks great. Okay, so now we know what compiler errors look like, but we can't just rely on compilers to catch all of our mistakes. You see, if you wanted to print I love Lucy to the screen, and you accidentally typed I love Martha, well, Lucy won't be very thrilled, but the compiler will happily translate your code into machine language, assuming you haven't made any syntax errors. This type of mistake is called human error. It's when our code is technically correct, but it does something we didn't quite intend. This type of mistake is not caught by the compiler. That's the problem with computers. They do exactly what we tell them to do. So it's our job to make sure our programs do exactly what we intend. Now, there are some things that we can do to make our code more readable for humans and less prone to errors. Let's talk about whitespace. The compiler ignores whitespace, meaning you can put blank lines as much as you want in your code, but don't go overboard. Too much whitespace and your code can be a little too scattered. Now, we can also use comments to make our code easier to read. We use a double slash to make single line comments. Anything to the right of a double slash is completely ignored by the compiler. It's stripped out of the code and doesn't even make it to the machine language version. We can use these comments to describe our functions and show exactly what it is that they do. Now, just like whitespace, comments can be used excessively as well. Oftentimes, it's better just to give our functions descriptive names so that it's obvious what they do. A descriptive function name is sometimes documentation enough and doesn't require a comment. Now we can also have multi-line comments. These are comments that span multiple lines, and you can open a multi-line comment with /*, and you close the multi-line comment with an */. Multi-line comments look like this. So here's another challenge for you. Open your hello.cpp source file and add some comments. Add a single line comment before each printf call explaining what it does. And then I want you to add a multi-line comment to the top of hello.cpp above the include directive, and I want you to put the name of the source file, followed by what the program does, and finally your name to show who is the author of this source file. Go ahead and pause the video now and give this a try. Okay, we're back and ready to comment our code. So here are our calls to printf, and just above the first one, I'm going to add a single line comment and say, print out my name. Just above the second printf call, I'm going to add another comment and say, print my hometown. And finally, I'll add another comment before our third function call, and I'm going to say, there is no beach in New Mexico. Okay, so now we want a multi-line comment. I'm going to add this at the top just above the include, and on line 1, I'll start the multi-line comment, and I'll give myself some space, and then on line 3, I'll do a */ to close the multi-line comment. Notice, before I did that, the entire program was green. It's all commented out. So I need to remember to close my multi-line comment. Now first I'm going to put the source file name hello.cpp. On the next line, I'll say print out my name, hometown, and my favorite hobby. And I'll go ahead and say by Steven. Now here's something that the C++ wizards often like to do. They'll put a star here at the beginning of each line, and this is not required, but it sort of shows you that each line is part of a multi-line comment. And so it kind of makes it look a little prettier. Now, to wrap this up, I'm going to compile this by going to Terminal and run build task, and I'm going to make sure that it compiles successfully, which it says build finished successfully. And I can click and hit any key, And if I hit /hello, well, there's my program. It prints my text to the screen just as I expect. Okay, this is going to wrap up this video. We have learned what a compiler actually is and why we need it to translate our C++ into machine language. We learned about compiler errors and how the compiler is capable of detecting simple errors like syntax errors, but we are responsible for making sure our programs do what we intend. Otherwise, we have what's known as human error, which is not detected by the compiler because it's technically correct C++. We also learned that whitespace and comments are ignored by the compiler, and we can use them to make our code more readable and provide some documentation so that we know exactly what it is that our code does. So now you have a bit of an understanding of why we need to compile our code, so you'll know what we're doing when we compile every time we make changes to our programs.